Okay. I have some graded homework problems that you can pick up after class. They're due on Friday, and I'll put the digital copy of that in today's folder, but those problems will be due on Friday. And chapter 2 is going to be basically about naming, and this is kind of new material, so I don't necessarily have any videos that go along with the naming, so I'll be doing a bit of lecturing and problems in class, but you could still take a look at it or skim through it ahead of time before you come to class, but there's no videos to watch because I don't have those videos. And we're going to do all of chapter 2 in terms of the naming, which started today with the basics in alkanes, alkyl groups. What issues do you have? Okay, well, then let's do this. Here's a problem from, and I can just make these problems up, although I oftentimes will get myself in trouble when I do that. But let me go ahead and just put this problem. This is one of the homework problems. So it's at the end, it's not one that you're graded on, but let's put this up and let's see what we can do with it. Okay, so give you a moment to sketch that out. So what is our first step?
Identify the longest.
So we got to find the longest continuous carbon chain in the molecule. All right, so take a minute and do that. And then I'll ask for a number. Okay, so as we're looking at, I want to know what the longest carbon chain is in this molecule. Give me a number. 9. 10. Any other numbers? We got a 9 and we have a 10. 8, 11, 7. So we have a 9 and a 10. Okay, where do you want to start the numbering? Here? No? Here? Here? Okay, tell me when you want to start the numbering. Or sorry, tell me when you want to start the longest chain. We'll number second. Do you want to start here? Yes? No? Okay. How about here? 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 So I heard yeses here, but then I heard no's. So if there's no no's here, or if you want to say no here, then it's got to start somewhere else. Here, let's do this. Cards don't work once I get past D. So just, how many people say you're going to have to be brave and raise your hand without looking around, seeing how many other hands are raised? Because once we go above D, I can't. The cards they don't make like a hexagon card, which they should. Okay, so how many people want to have the longest chain, not numbering, but have the longest chain start with A? Just raise your hand. No? 1. B. C. D. E. F. So D was the one that was where you want to start numbering. Or sorry, where you want the longest chain. All right, so let's start with D. So if we start with D, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you could have said A too. We could have started at A. So the longest chain goes from A to D. That's a 10 carbon chain. If you went from A to C, what would you have? You would just have a 9 carbon chain. So there are some hints I can kind of give you. I kind of work from left to right, and when I'm looking for the longest chain. So let me go so I can use my highlighter here instead of my. But I usually circle. So if I went with the longest chain, I would probably, I'm just looking for the longest chain. I'm not doing numbering. So I would go 1, 2, 3, 4, 5, 6, 7, 8. And then when I get to this point, I'm like, well, I can go 9 or I can go 9 and 10. So I'm going to end up like that. But I am going to try some of the other combinations. So I am going to, just to be on the safe side, I'm going to probably go 1, 2, 3, 4, 5, 6, 7, 8. No, I already know I've got a 9 if I go from A to C. 1, 2, 3, 4, 5, 6, 7. So the longest continuous carbon chain is going to be the 10 carbon chain going from A to D. And you really have to do trial and error on this. You have to start at the different end positions and kind of go around until you find the longest chain. Now the tiebreaker, if you have two longest carbon chains, is the one that gives you the most substituents. Okay. So if there were two 10 carbon chains in this molecule, you would basically choose the one that gave you the most number of substituents off of that longest chain. That's the tiebreaker rule for the longest chain. And if there's more than one longest chain that has the same number of substituents, then basically somebody screwed up in the problem. Because there is a level of tie breaking, but I never go to that rule. So usually, well, what it would mean is if I make that mistake on an exam, you get credit for both names. But there really should only be one name. That's what the IUPAC rules are about, so that everybody draws the same name. Okay, so we have this yellow as our longest chain at 10. Okay. Everybody okay with that? Now, how am I going to number the chain? From left to right or from right to left? Right to left? Agreed? How are we making that decision? We want a number at the end, from the end closest to the first substituent. So in this case, if I go 1, 2, 3, I encountered my first substituent at 3. Over here, if I go 1, 2, 3, 4, I encounter my first substituent at 4. And so I have to go from right to left. What are the tiebreakers here? The tiebreakers here are, let's say I've got this 5-carbon chain, and I've got 2 groups here and 1 group there. So the first tiebreaker is that you would number from the end if you have 2 substituents at one end and 1 substituent at the other at exactly the same position, the same first position. In this case, going from 1 and 2, I encounter a substituent. If I encounter 2 substituents versus 1 substituent, 2 wins. Okay, so we would number from this end. So if there's 2 substituents at that first carbon versus 1, 2 wins. That's tiebreaker number 1. Okay. And if something doesn't make sense, yell. Okay, because there's no, if you can come up with a flow chart on how you do this, more power to you. But it's kind of like we go off on a little bit of tangent, then we come back. So first thing was, how do you tie break the longest chain? The greatest number of substituents. How do you tie break numbering? The first thing is if there's 2 substituents from one end and another, and all this is that you go the same number of carbons in when you're numbering. So if there's a tie there, we break it based on the number of substituents, and if their number of substituents are the same, well, I should leave that there. So if the number of substituents is the same, let's say I have a bromine here and I have a CH3 here, then 1, 2 versus 1, 2, I'm tied. If I'm tied and this number of substituents is the same, I go with the first alphabetized substituent. So Br is bromo, Cl is chloro, F is fluoro, and I is iodo. Okay. So I noticed that in the book they didn't start with halogens. I like to start with halogens, quite honestly, because it gives me a greater number of problems I can work with. And these are relatively straightforward. And they're alphabetized on their first letter. So in this case, if I've got a bromo at 2 versus a methyl at 2, bromo wins. So it would be numbered, so this one would be numbered 1, 2, 3, 4, and 5. So those are our two tie-breaking rules. Greatest number of substituents, if there's more than one, and then same number of substituents first alphabetized wins.
So which rule would you apply if you had a methyl and an ethyl on 2 and 4?
If I had a methyl and an ethyl on 2 and 4, I would apply neither rule. Okay. So I'm actually not choosing between methyl and ethyl. Does anybody see why? Because I just changed the longest chain. So now this is my longest chain. I almost did that over here. And I was about to put that second group in, and I'm like, oh, I changed the longest chain. So now I changed the longest chain, so now it's a question of 1, 2 versus 1, 2, 3. And so I would be numbering from this end. So you have to be careful that you get the longest chain to begin with. But if it was, let's say, I can solve that problem by doing this. Okay. And I could do this one. Okay. And so if I did this one, the longest chain is going to be 1, 2, 3, 4, 5, 6, 7. Okay. And I probably shouldn't have put the numbers in, but I put them in the right way. But the longest chain would be this way. For those of you who are saying, well, why can't you draw the longest chain this way? And I would say you can. Because basically, if we come to a point like this, in one of the videos I recorded that I put on Piazza, I said this kind of like the fork in the road. If you come here to a fork in the road and it's the same group on either side, it doesn't matter which one you take because you'll end up with the same name. So in this case, I could use either longest chain because I'd get the same number. In this case, I'm going to number from this end because now this is ethyl versus methyl. Ethyl is first alphabetized, so coming from this end, it would be 1, 2, 3. Coming from this end, it's 1, 2, 3. And so ethyl, it would be 3 ethyl instead of 3 methyl because ethyl wins alphabetically. So it's if you have one substituent at the same position, it's just going to be based on alphabetization. But 2 versus 1, 2 always wins. Make sense? So if we go back to our problem here, I'm numbering from right to left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. Now, we said at the beginning that this was a 10-carbon chain. One of the things that, because I've graded thousands of these problems, I don't know if I'm in the tens of thousands, but thousands of them in my more than 25 years of doing this. And I feel every one of those days of 25. A student posted on Facebook, how come we didn't have a mole costume 15 years ago? I'm like, oh my God, it's been 15 years. Thanks for making me feel old. But one of the things that you can make a mistake on here is that you forget a number. So when you find the 10 longest chain, make sure your numbers go from 1 to 10 so that you don't skip a number. Okay. All right, so we go 1 to 10. Okay. So we found our longest chain, and we've numbered from the end closest to the first substituent. Now, sometimes what I will do before I even start numbering is I'll name the substituents, because if I'm going to need a tiebreaker, according to alphabetization, I need to already have named my substituents. So in this case, what is this group? That's an ethyl group. What is this group? That's a methyl. And what is this group? That's a methyl. And what's that group? Methyl. Now, I will suggest that when you first start doing these problems, that one of the things you may want to do, if nothing else with the substituents, is you may want to write in the carbons at the intersections of the lines and at the end of the lines. Write your carbons in, and then add enough hydrogens to give you 4 and only 4 bonds. So this would be a CH2, this would be a CH3, 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 and CH3, because sometimes when you first get started, it's easier to recognize that, oh, well, that's a methyl group. That's an ethyl group. That's an isopropyl group. So sometimes it's easier for you to recognize those groups with the carbons and hydrogens drawn in, at least initially, than it may be if they're just in the line bond structures. So if nothing else for the substituents, if you're kind of finding that, take a minute and write in the carbons and hydrogens. All right, so now we have our substituents and we have our longest chain. So the way every name works is that we create the parent name of the molecule first. And the parent name is always going to be the prefix for the longest chain, followed by whatever that functional group is, in what the highest priority functional group is in that molecule. Now, the reason I'm saying that is because as we go through the next few lectures, we're going to be changing the highest priority functional group. And there'll be a chart that you can use for homework that have the listing of the functional groups from the most priority down to the lowest priority. Okay? And in this case, we only have an alkane, so the parent name of this molecule would be that this is a decane. So decane tells me there's a 10-carbon chain and that I only have carbon-carbon single bonds. I have an alkane functional group. Okay. Now what comes before the decane molecule is a listing of the groups and where they're attached. So a number and the group. Now what we have to do is if any of the groups are the same, we have to collect those up. So for instance, I have 3 methyl groups here. So I need to collect those up into one listing. And so I use di, tri, tetra, penta, hexa. The only one that's different is like tri, tetra. Everything else kind of matches up with the alkane names.
So you said like highest priority functional group. So what determines priority?
So what'll determine priority is on Wednesday there'll be a double bond in here because we'll start looking at alkenes. And so if there's a double bond in there, that has a higher priority than an alkane. And so if there's a double bond in this molecule, it becomes a decene, D-E-C-E-N-E versus a decane. And when we get to a ketone, it'll be a decanone, or if it's an alcohol, it'll be a decanol. So this tells you what the highest priority is in functional groups, and we'll get to that. We'll start that on Wednesday as we go through all of the different functional groups. But right now we're just starting with alkanes. So they'll all be pentanes, decanes, nonanes, because that's all they have is carbon. The halogens don't count. Halogens are treated just like methyl, ethyl, propyl. They're treated the same. So that's what it'll mean as we go through those functional groups. Okay. So in this case, I've got 3 methyl groups. So this is going to be a trimethyl. And I need, whenever I have a tri something, there must be 3 numbers in front of that. So in this case, there's going to be a 3, a 5, and a 7 trimethyl. And so all 3 numbers have to be in front of a tri, even if 2 of the numbers are the same. Actually, even if all 3 of the numbers are the same. And you might say, how's that possible? That's possible when you have a halogen. So you have to have those 3 numbers. Remember, the goal of IUPAC names came from the idea that we want a single name that everybody will write. If there's a possibility of 2 people writing different names, then the rules have broken down. So if I said I had a 3,5-trimethyl, when you're writing that name, you would go, wait, where's the third one? Oh, well, they must have assumed that there were 2 7s. Well, wait, somebody else might have assumed there's two 5s. So that's why all 3 numbers have to be there. If it's tri. If it's tetra, there's got to be 4 numbers. If it's di, there's got to be 2. So you always have to have numbers, the same amount of numbers in front of the di tri. Because somebody who's writing the name, if it's not explicit, the name is wrong. Okay. So in this case, this is a 3,5-trimethyl. For alphabetization, for the moment, you never alphabetize the di, tri, tetra. You always alphabetize the group that comes after that. Now, there is an exception to that, which we'll get to. But for the moment, it's always, you never alphabetize di and tri. Okay, so that's going to be based on M. And then what do I have? I've got a 6-ethyl group. So now I put together my list. So this is a 6-ethyl. 3, 5, 7, trimethyl decane. Where do the commas and the dashes go? Dashes go between letters and numbers. Commas come between the numbers. So where you have more than one number, you put a comma, and then there's dashes that go in there. You may ask, is there a space or no space there? Technically, there's no space between the last substituent and the parent name, but I don't think that Top Hat asks you to write the name out. And if you write it either way on exam, I'll grade it correct.
So this is kind of an example, but like sometimes on bottles of isopropanol, I'll see that they just write 2-propanol. So how would that work with this?
So the common names that were in that listing of common names: methyl, ethyl, propyl, isopropyl, sec-butyl, tertibutyl, isobutyl. In the old system, those were what were called common names. And so if you have a bottle of rubbing alcohol that looks like this, it's made up of what we could call isopropanol because there's an isopropyl group attached to the OH. And we'll find out later this week that OHs are the alcohol functional groups. So you could call this isopropyl alcohol or isopropanol. But the IUPAC name, then you would find the longest continuous carbon chain, which is 3. So this would be a propan with this being an all, and where's the OH attached to 2. So when we get to that, I'll point out the fact that oftentimes you'll see the common name of the alcohol being the group plus the word alcohol, but the true IUPAC name should be 2-propanol. Now, the problem with the common names was, and you'll see this on some of my homework problems before I reconcile this whole issue, the common names that are there that I just listed that are on the sheet, and then they're on my handwritten sheet as well as they're on the blue book from the IUPAC, from IUPAC. There was a time where they separated the common name from the IUPAC name for an alkyl group. That led to the issue of there being more than one possible correct name. So what IUPAC said is, all these common names like isopropyl, we are now going to accept isopropanol as our IUPAC name, and that's it. So the groups that I have listed, those are all IUPAC names now. So if you have an isopropyl group, that's perfectly fine. Isopropyl is an IUPAC name. But there was a time when it was a common name. So in some of my homework problems, you'll see that I might have 3 or 4 different names because I didn't go back and change the answer keys. But the ones we're going to be using are just the ones that are in the blue book and also in that sheet. Okay, so those are the ones you got to know. And I've gone through, I went through on Piazza sort of a little video on sort of systematically how you can remember how those names are. If that system doesn't work for you, then you just might have to flat out learn them. Right? The M word, memorize. But if you use them enough, you go past memorization and learn them. So that's where it became different.
Can you explain how to find the longest chains for the bicyclic compound?
For the bicyclic compounds? Yes, I can. Are we okay with this? For the bicyclic compounds, the longest, so bicyclics have a different naming system. Okay, so for instance, if I have, I'll start with this one, which is the easiest one. You might want something more complicated. I think I have that on Top Hat. We can pull one of those up. But just to start with, the format for a bicyclic compound is this. It is bicyclo, then there is a bracket with 3 numbers, number, period, number, period, number. And then there is a name, and then there is an A and E. So this is the general format for a bicyclic compound. Now, what goes where? First, there is no longest chain in a bicyclic. It's the total number of carbons. That's the rule. So what goes here is the total number of carbons. So in this case, I have 1, 2, 3, 4, 5, 6, 7 total carbons. So this would be a bicycloheptane. So that A and E is the total number of carbons, not the longest chain. Now, the longest chain kind of comes into effect when there's a substituent. So I've got 7 carbons. So this is a bicycloheptane. Now, bicyclic compounds will have fusion points that make them bicyclic. That means 2 rings are fused together. So these carbons right here are the fusion points for the ring. So what we do is we look at this, we find those carbons that give us basically what I call a propeller. So if we look at this, if we look at these 2 fusion points, what we have is we've got this side, and this top side. So we kind of have a 3-position propeller. And so these are called the bridgeheads. Those are the bridgehead carbons. And there's always going to be 2 of those. Because the type of fused systems that we look at always have fused rings as opposed to, well, I just might as well, since I brought it up. Well, this, where there's just 1 fusion point, this is called a spiro. That's a spiro compound. We're not going to talk about spiro compounds. But that's 1 fusion point. We're going to always have 2 fusion points. So when you have 2 fusion points, those are the bridgehead carbons. And they create basically 3 propellers. And so the numbers that go in the brackets are the sizes of the propellers. In other words, over here I have 2 carbons, over here I have 2 carbons, and up here I have 1 carbon. So on the propellers I've got, let's say, I've got 2 carbons there, I've got, not green, but another color, yellow. I've got a yellow one there, and then I've got like a blue one there. So I've got these 3 propellers. And then what goes here are the sizes. So it usually goes in decreasing order. So it goes 2, 2, 1. So with bicyclics, this would be a bicyclo 2.2.1 heptane. Okay. And so thinking about that name, what it means is that if I wanted to draw that, if somebody said, hey, draw me a bicyclo 2.2.1 heptane, what you would do is you'd say, okay, well, I have 2 bridgehead carbons. And then off of those, what do I have? I've got a 2-carbon chain. Over here, I've got a 2-carbon chain. And then I've got a 1-carbon. There's propellers. I've got a 2-carbon propeller, a 1-carbon propeller, and another 2-carbon propeller. So I would be able to write my structure. And the double check here is that whatever this number is and the total number of carbons, the sum here is always 2 less because you don't count the bridgeheads when you're inside the brackets. So this would be a bicyclo 2.2.1 heptane. So there is no longest chain. It has a completely different numbering system.
So then I was confused on that. I think it was number 20, like how to number the branches.
Exactly. So let's look at that. Wait, let's go to full screen here. Oh, wait, maybe I just found it. I did. So this part right here in the textbook, I added that because I wasn't completely satisfied with what they were doing. So what I just wrote is this. Which one did you want? 20. Well, let's take a look at this one first. Okay. So you're supposed to match these up. right? Now, here's what I'll point out about these. First one, okay, just you're going to count the total number of carbons. This one right here, which you can't, well, okay, I can point. So this one, you're going to count up the total number of carbons. Here's a bridge. Here's a bridgehead. So this is going to be like a 1, 2, 3.1.1 bicyclo, whatever the total number of carbons is. Let's see, 3 plus 1 plus 1 is 5 plus 2 is 7. So this is going to be a bicycloheptane. Over here, we've got a bridgehead here, bridgehead here. We've got 1, 2, 3, 4, a 2, and a 2. So that's going to be a 4.2.2, which is 8, plus 2 is 10. So this is going to be a bicyclodecane. Over here, you'll notice, hey, there's no third propeller, because all you have is a bridgehead, but you don't have a third propeller. That's okay. The numbering scheme would be that this would be a 123.2.0 bicycloheptane, I believe. 3 plus 2 plus another 2. So if you just have two fused rings, one of the numbers is 0. Now, what about the substituents? So let's say here I have a substituent. And so how would we number this? Okay, so we'll do, this is 25. 26 looks like it's a little more complicated, but let's do 25 first. So let me take a screen capture. Let me go to PowerPoint. Let me see if I can paste it. Let me see if I can crop it quickly. Nope. Please just let me crop. Stop. Okay, so here's this one. Let's see if I can draw on it. All right. So this is going to be a, oh, it will let me draw. Really big. Okay, so what is this one going to be? How many total carbons? Now, this right here is my substituent. So the bicycloblank-ane is only going to be for the ring system, not the substituent. So in this case, I've got how many total carbons? 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be a bicyclo number octane. The CH3 is a substituent, it doesn't count. Again, if something doesn't make sense, you gotta yell. We okay? So now let's put the numbers in. So what are the numbers going to be? So it looks to me like I have a 3, a 2, and a 1. So I've got a bicyclo 3, 2, 1 octane. Agreed? How do we number for the methyl? Here are the rules. The rules are that we must start, rule number 1 is that you must start at a bridgehead. Must start at a bridgehead. Which one? Rule number 2 says that whichever one you start with, you have to move continuously by starting through the longest propeller, then the middle propeller, then the smallest propeller. So you start at a bridgehead and you have to move through the longest propeller, and it has to be all one numbering scheme. You can't pick up your pen at all. Okay. So how would I and what's my goal? My goal is to give, in this case, the methyl group the lowest number. If I have two substituents, my goal is going to be to give the first alphabetized substituent the lowest number. So, how am I going to do this to give the methyl the lowest number? Does anybody have a suggestion? I'm going to put an A and a B here. Which bridgehead do you want to start with? A, and how do you want to go? To the right. So this would be number 1, 2, 3, 4, 5, 6, 7. Sorry, you do have to pick up the pen to go to the last, smallest one. 8. That's a good question. So why did I go this way? Because rule number 2 says that we have to go through the longest chain, the longest propeller first, then the second longest, finally to the third. So if I started at A and went to the left, I would be violating rule number 2. So again, these rules are designed so that everybody names things the same. And so in this case, the rule is you have to go through the longest propeller first. Now, what if you had two propellers that were the same length? Now I got a choice, right? So I can go through the one that gets me the smallest number. So if there were 2 and 2, I could go through the one that gives me the lowest number of the methyl group. But then I'm still obeying rule number 2.
Now that we've found which number it's on, where do we
So then the substituent comes before the whole, this whole thing right here, that whole thing is the parent name. So the bicyclo number ane is the equivalent of pentane or hexane or cyclohexane if we had a cyclic compound. So it just comes before that. But the goal here, is to give the first alphabetized substituent, or in this case, the only substituent, the lowest number. So yes, in this group of things, in this group of readings for today, there was a lot of stuff. Alkyl groups, how to name alkanes, how to name cycloalkanes, that you didn't have any questions on, but we can certainly go over on Wednesday. Or again, if you post a question on Piazza, I will answer it by the end of the day. If I get something overnight, there's no way that's being answered overnight. So if you have those questions, otherwise come and see me. So for Wednesday, what I'd like you to do is to look over the alkenes. There's a bunch of stuff in there as well, but we'll go over whatever your questions are on Wednesday, lingering with these, as well as looking at with the alkenes. Okay. So those problems are due on Friday. You can go ahead and pick those up on your way out. Like I said, any questions, email me, post, and I will go ahead and